Example 13. Check whether the sequence 2n minus 7 upon 3n plus 2 is increasing or decreasing, and find out if it is bounded and convergent or not. Okay, so again this question is same as we discussed earlier. Now here sequence is given, bn is equal to 2n minus 7 upon 3n plus 2. Okay, so from sequence this is the nth number of term of the sequence. Now first of all we need to check whether the sequence is increasing or decreasing. So that's why we need to check the behavior of monotonicity. Now how to check? As we discussed in previous example, for this we need to take the difference between n plus 1 number of term and n number of term. Okay, so that's why here take bn plus 1 minus bn. Now what is the bn plus 1? Bn plus 1 means here n is replaced by n plus 1. So what we get? 2 n plus 1 minus 7 upon 3 n plus 1 plus 2 minus here bn term. So bn term we put as it is 2n minus 7 upon 3n plus 2. Okay, so here first is the bn plus 1 term minus bn term. Now simplify this. First multiply by 2. So we get 2n plus 2 minus 7 upon 3n plus 3 plus 2 minus this term is as it is. Now again simplify this. So we get 2n plus 2 minus 7, so minus 5, and 3 plus 2 we get plus 5. This term is as it is. Now here take the LCM, cross multiplication. So 2n minus 5 is multiplied by 3n plus 2 minus 2n minus 7 multiplied by 3n plus 5 divide by 3n plus 5, 3n plus 2. Okay, so here take the LCM for this. Now again simplify this. Now first 2n is multiplied to 3n. Okay, so 3 2s are 6n square. Again 2n is multiplied by 2. So we get plus 4n. Now this 5 is multiplied to 3n. Okay, so plus minus minus, 5 3s are 15, minus 15n. This minus 5 is multiplied to 2. Okay, so we get minus 10. Again minus as it is in second bracket. Simplify this. 2 3s are 6, 6n square. 2 5s are 10, 10n. 7 3s are 21, minus 21n. 7 5s are 35, minus 35. Okay, now denominator is as it is. Again simplify this. So 6n square plus 4 minus 15. So minus 11n minus 10 minus 6n square minus 10 minus 21. So minus 11n minus 35 as it is. Again denominator is as it is. Now open the bracket. So 6n square minus 11n minus 10. Here negative sign is there. Okay, so everywhere sign become reversible. Okay, so that's why 6n square plus 11n plus 35 upon denominator. So now 6n square plus minus cancel out. Again minus 11n plus 11n cancel out. Minus 10 plus 35 plus 25 upon denominator. Okay. Check whether this quantity is positive or negative. Okay. Here 25 is a positive number. Again here 3n plus 5, 2n plus 3n plus 2. Okay, so what is n? Okay, what is n? N is what? N is vary from 1 to infinity. Okay, so what is n? N is positive. Okay, so that's why this quantity is also positive. So the entire quantity is positive. So that's why we can write this quantity is greater than 0. Okay, so what we conclude? Bn plus 1 minus Bn is greater than 0 for all n. Okay, now shift this Bn this side. So we get Bn plus 1 greater than Bn for all n. So as per the definition, if n plus 1th number of term is greater than nth number of term, then the sequence is monotonically increasing sequence. Okay, so now let's discuss the next convergence of the sequence. So as per the definition, apply limit n tends to infinity, okay, on nth number of term. So limit n tends to infinity 2n minus 7 upon 3n plus 2. So now for this, Here n tends to infinity is given, so that's why we try to convert it into 1 upon n. So that's why divide numerator and denominator by n. So we get 2 minus 7 upon n, 3 plus 2 by n. Now put the limit. So this quantity becomes 0 and again this quantity becomes 0. So what is the answer? Answer is 2 by 3. Okay, and 2 by 3 is nothing but what? Approximate value is 0.6. Okay, so 0.6 is the finite answer. So what we conclude? The given sequence is convergent and converges to the value 0.6. Okay. Now let's discuss the boundedness of the sequence. Again, in previous example, we already discussed every convergent sequence is bounded sequence. Okay. So from this result, we can say that the given sequence is bounded sequence. Okay. Because this one is the convergent sequence. We already proved this. Okay. So that's why we can conclude that from this result, the given sequence is bounded sequence. But now let's check what is the lower bound and upper bound of the given sequence. So that's why in the given sequence, put the value of n. Okay, so this is my first term for n equal to 1, for n equal to 2 second term, for n equal to 3 third term, for n equal to 4 and so on. Okay, so now find the value. So what we get? Minus 1, minus 0.375, minus 0.091, 0.071, 0.1, 0.2, up to 0.66, up to 0.666. Okay, so here now observe the value of the sequence. So here what is the minimum value? Minimum value is minus 1. Okay, then value is increasing, and as we move towards infinity, it approaches to the value 0.6. Okay, so that's why what we conclude, this sequence lies between minus 1 and 2 by 3. Okay, so this is the lower bound of the sequence and this is the upper bound of the sequence. Okay, so that's why Bn is what? Bn is bounded sequence. Okay, and also from the definition of the convergence, what we conclude? This sequence converges to the value 2 by 3. Okay, so this one is nothing but the upper bound of the sequence. Means as we move towards infinity, the value of the sequence approaches to the value 2 by 3 but never exceed the value 2 by 3. मतलब कि जैसे हम infinity टर्म तक जाएंगे तो ये सीक्वेंस की वैल्यू क्या होगी? 2 by 3 को अप्रोच करेगी, लेकिन कभी भी 2 by 3 से इसकी वैल्यू ग्रेटर नहीं आएगी. ओके, सो दिस इज द मीनिंग ऑफ कन्वर्जेंस. सो सेम we apply here. The value of this sequence never exceed to the value 2 by 3. Okay, so this is the upper bound of the sequence. Okay, so from this we conclude that the given sequence is monotonically increasing sequence, bounded sequence and convergent sequence. Okay, and also converges to 2 by 3. I hope you all should understand how to solve this example.